Hey guys, welcome back to another video. So today we are gonna discuss about a new topic which is interesting and important, but yet it is a confusing topic. So it is from statistics and it's about hypothesis testing. So basically, hypothesis testing is a fundamental statistical method used to make inferences or draw some conclusions about a population based on a sample data. It involves making an assumption. The assumption is nothing but the hypothesis about a population parameter and then using sample data to test the validity of that assumption. So hypothesis is a theory proposed to explain a observation. So nothing but let's take example. What is this hypothesis means? For example, a new drug has been introduced in the market, and we just wanted to test on some sample data or sample. Let's take 10%. So whether, for example, let's take a drug is for to cure the headache or to cure the fever. Let's take fever, and so I'm giving this new drug to 10 people, and we are gonna test how fast this drug, I mean, the persons who are taking this drug, they are able to recover from the fever or recover from the headache. So if there is any significance difference after using the drug, then we can, that the statement is called the hypothesis. Like the new drug has some impact on the patients, and patients are, I mean, getting cured with that drug. So that is one example. So that is the statement is called the hypothesis, and we need to prove it. Then how to prove it? So we are going to talk about all these things in the next few minutes. So the population and sample, nothing but the population is nothing but the entire data we are talking about. It could be a population like entire, like if you are talking about a drug, then we need to test on some certain people, right? So the entire population, nothing but the entire people, and we are gonna test on a sample set of people. So like let's take, if I have 100 people, then I cannot take risk, and I cannot test my samples on like test my new drug on entire population. I need to take some sample and I need to test it. So that is about a sample. It could be like, so if I wanted to test a fertilizer, new fertilizer coming into the market, I cannot test it on all the plants. So I need to take a sample, or I need to a sample of some plants, and I need to test the fertilizer on those particular plants. That is for research purpose. And if there is any significant difference before and after taking, after giving that fertilizer, is there any significant difference whether that any cure or not? So that is what about a population and the sample. So here the image shows the same thing. So this is about the entire population, and this is taking some samples from the population. So we do have different terminologies in hypothesis testing, and the first thing is like null hypothesis, and the other one is alternative hypothesis. Null hypothesis is nothing but there is no significance difference. Like for example, we spoke about a drug, right? And it is not curing the fever. So that is means there is no difference. Even after taking the drug also, the person is not cured with that particular disease or particular headache, or let's say any disease. For example, the drug is being discovered for some disease, and but when I'm applying the drug to that particular person or sample of or set of people, and we are getting not the desired result, and there is no significant impact, that is means that is nothing but the null hypothesis. Null hypothesis is a statement of no effect, no difference, or no relationship. It is the hypothesis that the test seeks to disprove. So nothing but the new drug. So we are gonna disprove it. Like there is no significant difference, there is no impact on the person or on the disease. And let's take another example. The average height of a male student in the school is 170 centimeters. So this is my statement. This is my hypothesis. The average height of male student in a school is 170 centimeters. So I need to prove it. Like this hypothesis, I need to prove it. So after proving it, if I am able to prove that the entire school students average height is 170 meters, then that comes under alternative hypothesis. If I am not able to prove that statement, then that is a null hypothesis. So this is about alternative hypothesis. Alternative hypothesis is a statement that indicates the presence of an effect, difference, or relationship. Effect nothing but in the previous example, we spoke about a drug being introduced on to cure the headache. So after giving the drug, there is an impact. So there is a cure. So uh, if I if I gave this drug to set of people, then they're able to recover from that particular disease. So that means there is an effect. So there is a difference before taking the drug and after taking the drug. So that time, if there is any difference, that comes under alternative hypothesis. So this is about the below image, which explains about what is alternative hypothesis and what is null hypothesis. So here you can see we are applying some fertilizer to this plant, and after giving this fertilizer, biofertilizer, then there is a difference in the plant, like it grows healthy and as per the requirement, and the plant is growing healthy. So there is a difference. The application of biofertilizer X increases the plant growth. So the purpose of this biofertilizer is to increase the plant growth, and that is what happened after applying this biofertilizer. So that is nothing but there is a significant difference between the original plant and after giving the biofertilizer to that same plant. So that is nothing but the alternative hypothesis. The alternative hypothesis is a hypothesis which the researcher tries to prove. And so this is about alternative hypothesis. The application of biofertilizer hex do not increase the plant growth. So this is the same thing before and after. There is no significant difference. There is no effect of this biofertilizer. So there is no effect. There is no relationship. There is no difference. Then that comes under null hypothesis. The null hypothesis is a hypothesis which the researchers try to disprove or nullify. So this is a perfect example to discuss about what is hypothesis and what is null hypothesis and what is alternative hypothesis. So we have few tests to work further on this hypothesis testing. So and also we need to work on few terminologies, and I'm gonna explain what is this p-value and what is the significance level alpha. All these things we are gonna work on all these things in few seconds. So in statistic, a test statistic is a standardized value that is calculated from sample data during a hypothesis test. It is used to determine whether to reject the null hypothesis. So that is what about a test statistic. And common test statistics include z-square and t-scores, chi-square test values, and f values. So these are all the statistics to calculate the p-value. And we'll talk about what is the p-value. P-value is the probability of obtaining test results at least as extreme as the observed results. So assuming that the null hypothesis is true, a low p-value, though this p-values are like, if I'm getting a low p-value, that indicates strong evidence against null hypothesis. So you can reject the null hypothesis. And what is the significance level alpha? The significance level is the threshold used to decide whether to reject the null hypothesis. It is probability of rejecting the null hypothesis when it is true. Type 1 error. Common significance level researchers will give. This is before performing any test, we need to give it. We are not going to calculate it. So this is like we need to give it that 5% of the error, 1% of the error, 10% of very risky 10%. So most common significance levels are 0.05, nothing but 5 errors. So 0.05, this is the most commonly used alpha value, meaning there is a 5% risk of calculating that a difference exists when there is no actual difference. And if I want to give my significance level is 0.01, that is more conservative, used when you want to be more confident about the testing, then we should put alpha is equal 0.01. And if I give 0.10, that is nothing but 10% of risk of error, less conservative, used when a high risk of error is acceptable. High risk of error is acceptable when I give alpha is equal 10. So similarly for p-value also we have a lot of tests like z test, t test, chi-square test. So Pearson test, there are a lot of tests to calculate the p-values. So once we calculate the p-value, then we can conclude that whether to reject the null hypothesis or accept the alternative hypothesis. So the whole and sole idea here is like, is there any significant difference? If there is any significant difference or effect, then we will accept the alternative hypothesis. If there is no significant difference between the original and before testing and after testing, then we should accept the null hypothesis. That means rejecting alternative hypothesis. So let's jump into type 1 and type 2 errors. Type 1 error false negative, so rejecting the null hypothesis when it is true. There is a difference after giving some drug or so there is a difference or there is a effect. So that is called a type 1 error. Then we are going to accept the alternative hypothesis and we are going to reject null hypothesis. And the type 2 error is failing to reject null hypothesis, and we have failed to reject the null hypothesis when it is false. So that is about type 1 and type 2 errors. So these are all the basic steps if I wanted to perform hypothesis testing. So first we need to state the hypothesis. For example, my like assumption or my statement is like, okay, new drug is curing the fever. Like that is about, for example, let's talk about the previous example. Like the biofertilizer is improving the plant growth. So that is my hypothesis. I'm stating my hypothesis as the new biofertilizer is affecting the plant growth. The plant is able to grow healthy with that biofertilizer. And formulate the null and alternative hypothesis. Here, null hypothesis is like there is no growth in the plant even after applying the biofertilizer. And the alternative hypothesis is like there is a difference. There is a difference in the plant growth. So that is what we need to specify. These are all the steps in hypothesis testing. First null hypothesis, then alternative hypothesis, then choosing the alpha. So as I mentioned earlier, so we can choose by default 5% of margin of error or 1% or 10% is very risky. We are accepting high percentage of the error. So let's take alpha value is like 0.05. It's 5%. Now selecting the appropriate test. So as I mentioned, we do have z test, t test, chi-square test, and Pearson correlation test. We do have a lot of tests to calculate the p-value. Choose the statistical test based on the type of data. So these tests we have, why do we have a lot of tests? Because based on the statistical data and sample size. Example, ZT ANOVA chi-square test, that is based on the sample size and also the type of data we are working on. So based on this requirement, we do have different test statistics. Now the next step is collecting the data and calculate the test statistic. Now gathering the sample data and compute test statistics, determine p-value or critical value, and comparing the test statistic to a critical value or use the p-value to decide whether to reject or accept the null hypothesis. Make a decision, reject or fail to reject the null hypothesis. So that is what. And basically when to reject the, we discussed a low p-value. If I am getting the p-value is less than or equal to 0.05, this indicates strong evidence against the null hypothesis. Then we can reject the null hypothesis. If I am betting the p-value is less than or equal to 0.05. And let's talk about another example scenario. Let's say you want to test if a new drug is effective in lowering blood pressure, BP, compared to a placebo. So here how you would perform hypothesis testing. So now this is I states my hypothesis. Null hypothesis is like new drug has no effect on blood pressure. Mean difference is equal to 0. That is null hypothesis. If there is no difference, null hypothesis. Alternative hypothesis is nothing but the new drug lowers the blood pressure. So there is a difference after taking the or after giving the drug. Now choosing the significance level, I'm giving alpha is equal to 0.05, 5% margin of error. Then I'm selecting the appropriate test. Use two sample t-test to compare mean blood pressure between the drug and placebo groups. So collecting the data, calculating test statistic, and gather blood pressure readings from both the groups, determine p-value. So same procedure. If I'm getting p-value is less than 0.05, then I'm rejecting the null hypothesis and accepting the alternative hypothesis. I'm saying that okay, this new drug has an effect. This can cure the or this can lower the blood pressure. There is a significant evidence to suggest the new drug lowers the blood pressure. So that is about example scenario how this hypothesis testing works. So as I said, there are a lot of tests based on the data we are working and based on the sample size we are taking. So we do have Z test, T test, ANOVA, chi-square test. So let's talk about those test statistics. So so first we'll talk about Z test use case. So when do we use Z test rather than other test? So Z test use case is like uh, comparing the mean of sample to a unknown population mean. So Z test is nothing but comparing mean of sample to a unknown population mean. So that is where we can use this Z test. And example case is like the average height of male student is 170 centimeters. Alternative hypothesis is the average height of male student is not 170 centimeters. So this is how we can calculate the Z score and P value by using Z test. So I'm importing NumPy as NP matplotlib. I just wanted to show the data visually, and I'm importing this stats from this SciPy. So I'm just giving. So this is my null. I'm stating the. So see, my use case is comparing mean of sample to a known population mean. So I stated the average height of male student is 170. I'm saying that null hypothesis, and alternative hypothesis is average height of male student is not 170 centimeters. So I'm giving the sample data of 170, 168, 165, 172, 7 students data I have given, and I'm stating that population mean is 170 centimeters. So sample mean, I'm calculating the sample mean, and also I'm calculating the sample standard deviation. So this is number of samples I'm taking. I'm z-score and p-value. So after calculating the z-score and the p-value, if I'm getting my p-value is less than 0.05, then I can accept that the average height of the male student is not 170 centimeters, which is more or less than 170. If I'm getting p-value is greater than 0.05, then I need to approve the null hypothesis and accepting the null hypothesis, which means the average height of a male student is 170 centimeters. So I just wanted to visualize the same thing. So with the matplotlib, here you can see. So this is density, and these are all the my z score values. So this is a standard normal. This is distribution and rejection region. This is rejection region. Z-score I'm getting 1.26. So here, if anything, the value presents here, this is acceptance region and this is a rejection region. So this is about how test statistic using Z-test. So we do have T-test also. Use case is comparing means between two groups, independent or a paired group. and now I need to state the null hypothesis and alternative hypothesis. There is a difference. There is no difference in test scores between two teaching methods, like teaching method and teaching method A and teaching method B. If there is any significant difference, then that comes alternative hypothesis, and there is no difference. If I give any teaching method, there is no significant difference for in the marks of the students, then that comes under null hypothesis. So I'm giving two groups with the scores. So my group one students, 5 students I have in the group one, 85 marks, 86 marks, 88 marks, 75, 78, something like that, and group two. And I'm calculating the t-test and p-value by using this formula using the Python. And if I wanted to plot a graph, so my group one and group two. So this is the t-test visualization. And so this is my group one, and this is my group two. Group 1 mean is 82.40 marks and group 2 mean is 77.60 mean. So this blue line indicates the group 1 mean, which is 82.5, and this is 77.5 is a group 1 mean, group 2 mean, sorry. So after calculating the t-test and p-value, if I'm getting the p-value is 0. Less than 0.05, then I can able to say that okay, there is a significant difference if I am teaching a different ways, like group 1, group 2. If I am my teaching ways are different, then there is a significant difference in the student marks. So that is how I can comes to a conclusion by using t-test. And also similarly for ANOVA, analysis of variance. This is about analyzing a variance, comparing means across multiple groups. And here I am giving an example of there is no difference in sales across different regions, and there is a difference in sales across different regions. Now I need to prove it. Group 1 sales, group 2 sales, group 3 sales, and I'm calculating FP. And after calculating the p value with this ANOVA analysis of variance, so this is my region 1 sales, region 2 sales, and region 3 sales. So sales are like 80 and 60 and 40, something like that. We can work on ANOVA. So basically why we are taking different kinds of test statistics is like, so we need to standardize the value that is calculated from sample data during a hypothesis test. So it is used to determine whether to reject the null hypothesis. Common test statistics are, that is why we are discussing about z, t, chi-square and f values based on the data we have. So in the first example, we just have the data, a numeric data of only one set of data, only one class of student or one school of students. I'm gonna work on those data. So whereas in the second example t-test, so two samples we are taking, group 1 and group 2. So if I have two sample, one sample t-test we have, so here we are taking two samples for two groups. And whereas here ANOVA analysis of variance, we are taking three groups of cells and calculating the p-value to just to accept or reject the null hypothesis. And chi-square test use case is like testing relationship between categorical variables. So when I'm working on any categorical variables, though I can able to work calculate the test statistic by using chi-square test. So this is how you can calculate it. So this is my data category 1, category 2, and this is how I can calculate the chi-square and p-values. And this is my uh, validation test visualization. So this is about chi-square test. These are all like based on the data type we have, what kind of data and how much is the sample size we are using. So in that way, we will use this different type of tests. So basically Z test and T test to determine if there is a significant difference between the means. So my mean sample 1, sample 2 are main population to determine if there is any significant difference between the means. And ANOVA test is to compare more than two groups means simultaneously. So that is where we can use this ANOVA test. analysis of variance. And chi-square test is like to check if there is a association between the categorical variables. So I have two categories. Is there any correlation or association between the categorical variables? Then we should work with the chi-square test. And we do have another test statistic, which is Pearson correlation test, to access the linear relationship between the continuous variables. So this is about the correlation test, testing the strength of association between the two continuous variables. So this is how I'm stating my null hypothesis and alternative hypothesis. There is no correlation between hours studied and exam scores, and there is a correlation between hours studies and exam scores. For example, a student is studying for 10 hours, he is getting better results, like he's getting more than 85% or 90%. And for other students who are studying for less than 8 hours, then they are getting less score, something like that. If there is no difference, if I'm studying 10 hours or 20 hours, still I'm getting 60 percentage of the marks. And if person is studying 1 hour 2 hours, they are also getting the 60%. There is no difference, right? So that is about the continuous variables, how this Pearson correlation uh, test works. And the main applications, real world applications, are like A and B testing in market campaigns, like for example sales, whether the particular new product, after introducing the new product, there is any improvement in the sales or not. So quality control in manufacturing, like drug quality controls, by working on the sample data, we are gonna look how the new drug is performing, how the quality. And also clinical trials in healthcare, like this biofertilizer, something like that. So this is how this is about the hypothesis testing, and which is very useful in machine learning, especially when we are working or when we are able to build some models. So it is a bit confusing, but it is very easy and interesting topic. So if you are getting something, like if you are able to understand which are looking something about hypothesis testing, and you are able to get it something here, please do subscribe the channel. If you are really like the video, please like the channel. And if you really love the entire all the videos, don't forget to subscribe the channel. Thanks guys, see you in other video. Bye.